Hello and welcome to this series of videos on mole calculations. So we're going to be talking about what a mole is. It's not one of those. What we're going to be looking at is we're going to be looking at mole calculations, and we're going to be talking about amount of substance. And what we're going to look at to start with is what you need in order to tackle a mole calculation and where you get the information to do just that. So let's jump in and start working through some moles.
Okay, so I've already said that moles is an amount of substance, but what is a mole? So some numbers that you might be familiar with: if I have a couple of something, I have 2 of that thing. So if I have a couple of apples, I have 2 apples. If I was to say how many eggs are there in a dozen, you'd probably go, well, there are 12 eggs in a dozen eggs. So okay, what about mole? If I had a mole of something, how many would that actually be? So a mole of something is 6.02 times 10 to the 23. Okay, that's how much a mole is. That is a huge number. Okay, what it is the number 6 followed by 23 zeros. And there's a 2 there as well. So it's 602 and then 21 other zeros. It is a massive number. Okay, just how massive a number is it? Well, if I was to have a mole of apples, okay, so go to our 2 apples, a mole of apples, so I've got 6.02 times 10 to the 23 apples, it would be about as big as the Earth. Okay, that's how big a space that mole of apples will occupy. Now, if you look up how much of a mole of something would something be, there's loads of things on the internet that tell you just how vast this number actually is. So how do we use it and how does it make sense? Okay, so let's look at a few basic sort of equations. Okay, so if I was to think about an equation that some of you already talked about, maybe with some of your metals, we could talk about the fact that some magnesium reacts with some hydrochloric acid to form magnesium chloride and some hydrogen. Okay, so this is an equation involving a metal and an acid. Okay, you recognise this as the MASH equation. So how does moles fit in? Now, if we talked about particle theory, and probably when you first learnt about reactions, you would have talked about, well, what this means. It means that if you have 1 magnesium, so let's say this is our magnesium here, and then we had some hydrochloric acid, I'm just going to mark this as just something slightly different. What this would essentially say is, well, I'd have 1 magnesium would react with 2 hydrochloric acids. And then what that would make is it would make 1 magnesium chloride and we'll have 1 hydrogen. So that's sort of how you may have learned about it, like a little bit of particle theory. So where does the mole fit in? Well, actually it's not just sort of 1 particle of magnesium reacting with 2 particles of hydrochloric acid. What this equation actually means to a chemist when they understand moles is it means that what we have is we have 1 mole of magnesium reacts with 2 moles of hydrochloric acid to form 1 mole of magnesium chloride and 1 mole of hydrogen. Well, how did I know that? Well, all I need to look at is the big number that's in front of things. So when I'm thinking about how many moles of something there is in an equation, I look at that number. So chemists don't write the number 1, okay, we just leave a space, because we assume whenever there's no number that number is 1. Okay, if there's a number 2, it means that there is 2 moles. Here we've got another gap, so it's 1 mole, and here we've got another gap, that's 1 mole. So that's what a mole actually means to a chemist in some ways, is we can look at reactions and we can say, well, if I have a certain amount of this, it will react with a certain amount of this to make a certain amount of the product that I'm interested in. And we can't work with particles because they are so tiny. We have to think about a larger number, and that number that we have to use, okay, is that 6.02 times 10 to the 23. So what I've just been talking about is essentially what a mole is and what it means to a chemist, and how actually it changes the way that we read chemical equations. Now, what this is actually all about for you is a mole calculation. So what mole calculations do you need to know, and in what kinds of ways will you be asked about them in your exams? So to start with, I'm just going to start with the basic ones of how much of a substance you have, or how many moles of that substance you have. So for instance, a question could be phrased in one of two ways. You could be asked about the number of moles of something. So you could be asked, okay, if you have so much of this, if you have 12 grams of this substance, okay, how many moles is it? The other that you could be asked is, what's the mass of a substance? I.e., I have 3 moles of this substance, how many? What's the mass of it? So there's a little bit of information gathering that you need in order to do these calculations. Now, let's say that we work with a question such as this, okay, as an example that we're going to talk through. So, how many moles is 12 grams of carbon? Okay, so that is our question. How many moles is 12 grams of carbon? Now, in order to work this out, we've got to use an equation, okay, and this is an equation that you need to remember. Now, the equation is that moles equals the mass divided by the mR. Now, I'm already saying, okay, well, here's something that's new. What on earth is this? Okay, this little symbol, mR. Okay, now mR can mean a number of different things. To start with, we're just going to talk about a question that has an element in it. So in this question, we're talking about carbon, which is an element. So when we're thinking about what our mass is going to be, our mass is going to be from the periodic table. So where do we get this from on the periodic table? Well, what we're interested in is we're interested in the mass number. So for our carbon, if we were to look on the periodic table, okay, we would see this. Okay, thinking back to a previous lesson that we talked about, these two numbers have a meaning. Okay, the bottom one is the atomic number, this one is the mass number. So we're interested in this bigger number here. Okay, we're interested in this 12. So what we know is we know that the mR of carbon is 12. Okay, so let's go back to our question, how we go about working through it. So we've got moles equals mass over mR. So our question is, how many moles is in 12 grams of carbon? Okay, so my moles is going to equal 12, okay, which is the mass of carbon that we have in the question, and 12 is our mR. So we've got 12 divided by 12, which equals 1 mole. Okay, really easy example, just to go through there. Okay, so I've got my mass, okay, from what I've got here. So I've got my mass, okay, from the question up the top, 12 grams. Okay, and I've got my mR, okay, from the periodic table, which is 12. Okay, so let's look at another example, and we'll change things up a little bit. So we've got to remember that moles equals the mass, okay, divided by the mR. Okay, so that's the equation that we need to remember. You can also do this in a formula triangle. I know some people like to use these. Okay, so if we're writing this into a formula triangle, it looks a little bit like this. Okay, now I could just about fit it in. So what we've got to think about here is you might get another question that asks you something along the lines of, what mass does 2 moles of lithium have? Okay, so this is a slightly different question. Okay, what mass does 2 moles of lithium have? So we've got to rearrange this equation. Okay, so this is a skill that you've got to be able to do. So before we sort of address what's in the question, okay, we're just going to rearrange the equation. So up here, okay, we've got moles equals mass over mR. We're looking at the mass. So what we've got to do is we've got to move the mR from here, okay, to the other side of the equation. So the way in which we do that, okay, is we multiply both sides by the mR. Okay, so what that means, it means that my mass here, okay, becomes just the mass, and over on this side of the equation here, okay, on the left-hand side, we're going to have moles multiplied by mR. So what we end up with is we end up with moles multiplied by mR equals the mass. Now the other way of doing it is using this formula triangle. So we've been asked to calculate the mass. So what we do is you'd get your sort of imaginary hand and you'd cover up the mass, and that leaves you with moles multiplied by mR. Now conversely, if we were going back to the last question, doing a moles calculation, I would cover up what I want, so I'd cover up the moles, and that would give me mass divided by mR. Hopefully that makes some sense. Okay, so back to the question. So we've now rearranged this, so we know that our mass equals our mR times by moles. Okay, so we know how many moles we've got because that's written in the question. Okay, but what we do need to work out is we need to work out what the mR of our lithium is. When you look at the periodic table, what you'll see is you'll see that lithium has the following 7 and 3 Li. So using what we knew in the last question, we know that the mR of lithium is going to be this number up here, R7, just there. So what we've got in our question now is we know that we've got the number 2 for our moles, we've got the number 7, for our mR, and then we've got our mass, so 2 times 7 is 40. Now a key thing about mole calculations is you need to remember units. So the units of moles you can just write as moles. So if you're talking about how many moles you've got, you could say 2 moles. When we're talking about mass, our mass is in grams. Now the last unit I'm just going to talk about is what the unit of mR is. So the unit of mR, is simply, grams, per mole. Grams per mole. So that's how the units look. Now we don't like writing things like that. So the way in which we write it is we write it as grams per mole. That's how we like to write it, and it's essentially the mR is just how many grams there are in 1 mole. So we like to write it like so. So this is the units of relative atomic mass, of molecular mass, of compound mass. So that's a couple of examples involving elements. So I'm going to give you a question on that. I want you to have a go at it, work through it, see if you get the right answer, and then we'll talk a little bit about compounds. Okay, so here's a question for you. So how many moles is 67.5 grams of aluminium? So what I want you to do is pause the video, have a go at doing this question, and then follow through to see if you got the right answer. So best of luck, off you go. Okay, here we go. Let's see how well we've done on this question. So, how many moles is 67.5 grams of aluminium? First step, I'd hope that some of you are thinking about highlighting some of the key stuff in the question. So we've got the number of moles, how many moles, we've got our mass, and we've got aluminium. So that's some of our key information in the question. So step number 1, I'm going to write out the equation. So I'd have moles equaling mass divided by my mR. So we've talked about that a couple of times now. I put in the information that I know from the question. So I don't know what the moles are, that's what my question's all about. I know my mass because it's 67.5 grams. And I need to find out what my mR is to put it down here. So where do I go? Periodic table. I have a look on the periodic table, I'll find aluminium, and I'll find that it has a mass number of 27. So I put in my 27. Plug that into my calculator, and I'll end up with the answer 2.5. So 2.5 moles. So when reviewing this, there's 2 parts that you need to make sure you're getting right, using the correct equation, and then getting the answer right at the end. So well done if you managed to get 2.5. So what about some different examples? What about when we've got something that exists diatomically, like oxygen, O2, or we've got a compound like methane? So I'm going to talk about these in another video. I'm going to pause this video here so you can sort of reflect on looking at elements in these calculations, and then I'm going to do a brief video afterwards just talking about compounds and diatomic molecules and the slight difference in the steps that we need to do for these calculations. So I hope this has been useful. Please tune into the next video, follow this little series on mole calculations along, and hopefully they'll help you with tackling some exam style questions. So thank you very much for watching, and I'll catch you in the next video.